Turns out, the cognitive reserve script. Your grandmother took up watercolor painting at 72. Your uncle started learning Italian on an app at 65. Your neighbor joined a book club at 58. We tend to think of these things as cute hobbies, ways to stay busy in retirement. But here's what neuroscientists in Italy just discovered. The people who do these things may be fundamentally rewiring their brains in a way that could delay or reduce the severity of Alzheimer's disease. The question isn't whether hobbies are nice to have. The question is, why are we not treating them like medicine? So here's what we need to talk about. Alzheimer's disease affects roughly 6 million Americans right now. It's the 6th leading cause of death in the United States. And it destroys not just memory, but the entire architecture of self. For decades, researchers have been hunting for preventive factors, things that might slow the disease or help people resist it longer. They've found exercise, they've found diet, they've found sleep. But one thing kept popping up in the data like a ghost: education and lifelong learning. The problem was that nobody really understood the mechanism. Was it that smarter people were more resistant to disease? Was it that educated people had better access to healthcare? Or was something else going on? That's where a team of Italian neuroscientists decided to look more carefully. They wanted to understand not just whether learning matters, but how it works, and whether it matters at every stage of cognitive decline, from healthy brains all the way through to full dementia. This research comes out of multiple institutions in Italy, primarily the Fondazione Santa Lucia in Rome and the University of Turin. The lead author is a woman named Serra L, working with colleagues including M. Bozzali and others across 5 different neuroscience laboratories. This is the kind of work that emerges from real clinical environments where neurologists are seeing patients at different stages of decline and asking, why do some people hold on better than others? The study was published in Frontiers in Aging Neuroscience in May of 2026, and it represents a fairly recent attempt to answer a question that's been lurking in the background of dementia research for a long time. Here's what they did. They recruited 286 people. Some were completely healthy. Some reported worrying memory issues, but no actual cognitive decline. What researchers call subjective cognitive decline, or SCD. Some had what's called amnestic mild cognitive impairment, where memory loss is real and measurable, but not severe enough to be called dementia. And some had full Alzheimer's disease diagnosis. Think of it like a disease continuum. Imagine a bridge from healthy cognition to full dementia, and they stationed people at different points along that bridge. Then they asked them 2 key things. What's your educational background, and what leisure activities have you engaged in throughout your life? Not just now, throughout your whole life. This is crucial. They weren't looking at what people do in retirement. They were looking at cumulative cognitive engagement across decades. They then measured their actual cognitive performance using standard neuropsychological tests, and analysed whether the people with more education and more lifelong leisure activities performed better than those without, and whether this protective effect showed up at each stage of the disease continuum. What they found was this. Education mattered. Lifelong leisure activities mattered. But, and this is the interesting part, they didn't matter the same way everywhere. Let's start with the healthy people. Those with higher education and more leisure activities scored better on cognitive tests, but this is almost unsurprising. We'd expect that already. But then look at what happens as you move down the bridge. When you get to people with subjective cognitive decline, people who think something is wrong but test normally, the protective effect of education and leisure activities becomes sharper. It's like their cognitive reserve is actively defending them. They have accumulated brain resilience. Then in the mild cognitive impairment group, you still see this effect, but here's where it gets complicated. The relationship isn't perfectly linear. It's not like more education equals perfect protection. Instead, what the data suggests is that certain types of leisure activities, particularly cognitively complex ones, ones that require you to learn something new or engage in problem-solving, seem to provide more benefit than passive activities. Reading complex books appears to offer more protection than watching television. Learning languages or musical instruments offers more protection than, say, going for walks, even though exercise is independently protective for other reasons. The effect sizes aren't enormous. We're not talking about the difference between guaranteed dementia and immunity. We're talking about measurable differences in how long people maintain function and how steep their cognitive decline is. But across a population, measurable differences become significant. Here's what this means for the actual people in your life. If someone is 60 now, the message isn't, start doing hard cognitive stuff or you'll get Alzheimer's. The message is more nuanced. Regular engagement with learning and complexity throughout your life appears to build a kind of cognitive cushion. When disease processes start, and many of us will have some Alzheimer's pathology in our brains without symptoms, that cushion buys you time. It delays when you notice problems. It slows progression. But, and this is important, it's not a cure. Someone with lifetime intellectual engagement can still develop Alzheimer's. The protection is probabilistic, not absolute. There's also an honesty check we need to do here. This study is observational. That means the researchers looked at patterns in data, but they didn't randomly assign people to learn French or watch TV for 30 years and see what happens. So there's always the possibility that the same traits that make people engage in lifelong learning, conscientiousness, health orientation, socioeconomic advantage, access to education, are also driving the cognitive benefits. The study can't completely disentangle that, but the authors tried to account for these confounding variables, and the effects held. This research slots into a broader picture of cognitive reserve, this idea that the brain has a capacity to resist damage. It's like your brain has structural redundancy and functional flexibility. If one area gets damaged, other areas can pick up the slack. Education and complex leisure activities seem to build that redundancy over decades. This connects to other work showing that bilingualism, musical training, and cognitively demanding careers all seem protective. What's particularly valuable about this Italian study is that it maps these effects across the disease continuum. It shows us this isn't just about keeping healthy brains healthy, but about the progression of disease in people who are already affected. The next question, the obvious one, is whether it's too late to start. If you're 65 and you've spent your life in a job that wasn't intellectually demanding and you haven't had much time for complex hobbies, can you still build cognitive reserve? The honest answer from current research is probably somewhat, but we don't know the timescale or the size of the effect. That's the research that needs to happen next. We need intervention studies. We need to know if starting complex learning now has measurable effects on disease progression in people already showing signs of decline. Here's what sticks with you from all this. The brain isn't static. Even in the face of disease, the architecture we've built through learning and complexity seems to give us resilience. You can't think your way out of Alzheimer's disease, but the thinking you do over a lifetime might determine how long you preserve yourself. Not bad for a hobby. Turns out, scientists have been busy, and they're not done yet.